In this video, we're going to talk about dimensional analysis when it deals with dealing with pharmaceuticals. Pharmaceuticals are a little more complicated, and you need to be a little careful. Those of you in the allied health field will have more of these when you get into further classes in your field. When we work with dimensional analysis in pharmaceuticals, we have to look at what the doctor has ordered and what we have in the label or on the label. So, for example, in this problem, the order was for Phenergan, 12.5 milligrams, but the label, the actual product that the hospital or the pharmacy has on hand, is in a liquid form, and it has 25 milligrams per milliliter. So when you work with dimensional analysis with pharmaceuticals, you always start with the order, and then you work with what's on the label. So we have the order, then we go to what is on the label, and then any converting. By having these two front and center, we can then do any necessary conversions. So if we start with the order in this example, it's 12.5 milligrams, and we're going to multiply it by the label. Now recognize this label is actually 25 milligrams per milliliter. So we do want to be a little careful when setting up our conversion. If I would just write in 25 milligrams per milliliter, we're now going to have milligrams squared. So we don't want that. So we'll have 1 milliliter per 25 milligrams. And then if we do the math, we get 0.5 milliliters because milligrams canceled out. Now sometimes we have to do a conversion. So how many teaspoons of dilated cough syrup should be given if the order is for 1.5 milligrams and the label reads 1 milligram per 5 milliliters? Now notice they want to know how many teaspoons do we need. So we'll start with the order. The order is for 1.5 milligrams times, now the 1 milligram per 5 milliliters. We don't want to write it like that because milligrams times milligram is the milligram squared. So we'll put 5 milliliters per 1 milligram. At this point we can cancel. But if we stop here, our current unit is milliliters. The problem wants to know in teaspoons. So to do a conversion with teaspoons, we could go to our search engine, type 1 teaspoon or teaspoon to milliliters, and we'll find out that 1 teaspoon equals 5 milliliters. Now again, since our goal is to cancel, we'll put 1 teaspoon at the top in the numerator over 5 milliliters. That cancels out, and we're left with 1.5 teaspoons. Now this problem was using a factor of 5, and our conversion for teaspoon is a factor of 5. So you just don't cancel things out and say, okay, it's just 1.5 teaspoons. This problem just happened to work out like that, but you won't always have those types of problems. Well, sometimes when you do these types of dimensional analysis, we need to take into consideration the weight of a patient. So this problem, how many milliliters of thiabenzidole suspension should be given to an adult weighing 148 pounds if the order is for 25 milligrams per kilogram and the label reads 5 milligrams per 5 milligrams? So we have really 3 pieces of information. We have a patient's weight. Some pharmaceuticals will take into consideration the weight of the patient, while others may not. This one does. The order is for 25 milligrams per kilogram, and the label reads 5 milligrams per 5 milliliters. Now in this problem, I'm going to start a little differently. I'm going to start with the patient's weight. So 148 pounds. And then we're going to multiply it by a conversion. For every kilogram, that is equal to 2.2 pounds. And I'm going to use a hashtag so I don't have to write out pounds. So at this point, if I cancel out the pounds, I just have the weight of the patient in kilograms. So now I'll put in the order, which is 25 milligrams per kilogram. And you can see we can cancel the kilograms. And then 5 milliliters per 500 milligrams. And if we cancel those out, we now have our ending unit, which is in milliliters. As we did with the previous problem, let's go back to that real quick. When we work with milliliters, milligrams, milliliters, we want to make sure that we aren't creating any weird units. So as we did here, we had the milliliters in the numerator and denominator, so they canceled out. This problem requires the same thing. So if we multiply and divide this out, we get 16.8 milliliters. Now it is a good habit to get into to always include your milliliters or your units. If I would just write in 16.8, people are going to ask, well, 16.8 of what? Now to do this on your calculator, there's a couple of ways you can do it. Probably the easiest way is to type in 148 times 25 times 5. That gets all of the numerator. And then divide by 2.2 and divide by 500. And that would get our denominator. Nothing preventing you from doing multiplication, division, multiplication, division, multiplication, division as you work across. Those are 3 examples on how to work with dimensional analysis with pharmaceuticals.